Okay, so this is part 2 of section 6.5. So in part 1, we were looking at inverse sine, inverse cosine, and inverse tangent. So now we're left with the 3 other inverse trig functions. In part 1, we did go through the graphs of cotangent, cosecant, and secant, and we restricted their domains so that they are one-to-one functions. So based off of those graphs, let's go ahead and state the domain and range of inverse cotangent, inverse cosecant, and inverse secant. And remember, since they're inverse functions, the domain and the range switch. So inverse cotangent, which can also be written as arc cotangent, okay, will have a domain of all real numbers because the range of cotangent is all real numbers. And then the range of inverse cotangent is going to be between 0 and pi. Okay, not including the endpoints 0 and pi, because the restricted domain for cotangent, forcing it to be a one-to-one function, would be between 0 and pi. I think it's helpful to kind of get a visual of what that range looks like on the unit circle. So let me just draw a sketch of a unit circle. So I'm going to say that that's my unit circle, and I'm actually going to copy that so that I can paste it for the other ones as well. Okay, so that range from 0 to pi, that gives us angles in quadrant 1 and quadrant 2. Inverse cosecant, well, the range of cosecant is from negative infinity to negative 1, union 1 to infinity. So that means the domain of inverse cosecant will be negative infinity to negative 1, union 1 to infinity. And the restricted domain for cosecant, forcing it to be 1 to 1, was from negative pi over 2 to 0. And then union 0 to pi over 2. So that means the range of inverse cosecant will be that interval. We're excluding 0. Okay, and if we think about on the unit circle where that would be quadrant 4, would give us the angles from negative pi over 2 to 0. We're excluding 0. And then 0 to pi over 2 would be from angles from quadrant 1. So the negative angles, remember, are rotating in the clockwise direction. So, oops, like this way in the clockwise direction. And the positive angles would be rotating in the counterclockwise direction. Okay, inverse secant, okay, also known as arc secant. Oh, I forgot to put the arc cosecant notation. Okay, so arc secant. Domain is also going to be negative infinity to negative 1, union 1 to infinity, because that's the range of secant. And then that restricted domain for secant was from 0 to pi over 2, union pi over 2 to pi. Okay, which is now the range of inverse secant. And on the unit circle, that would be from 0 to pi over 2 would be quadrant 1. So angles in quadrant 1. and in standard position, rotating in the counterclockwise direction. We exclude pi over 2, and then pi over 2 to pi would be quadrant 2. Okay, so notice that the range for inverse cotangent is really different from inverse tangent. Remember, the range for inverse tangent was from negative pi over 2 to pi over 2. So those are totally different quadrants on the unit circle. Inverse cosecant is pretty close to inverse sine. At least they're the same quadrants, quadrant 1 and quadrant 4. But sine is from negative pi over 2 to pi over 2, whereas the range for inverse cosecant excludes 0. And then inverse secant is pretty close to inverse cosine, the range of inverse cosine, in that they're angles from quadrant 1 and quadrant 2. However, inverse secant excludes pi over 2. Okay, and I'll touch on why I pointed that out in a second. So just a note, the reciprocal approach cannot be used for inverse functions. Like inverse cosecant is not equal to 1 over inverse sine, unfortunately. But if you think about it, inverse cosecant represents an angle, and like the reciprocal of the angle would not be that equal to the same angle as 1 over inverse sine. Okay. Now, these are the identities. Note, I don't know if you guys had checked out on your graphing calculators yet, but if you hit the second button and then sine, cosine, or tangent, or we've used them before, right? When we were solving triangles, you can pull up inverse sine, inverse cosine, or inverse tangent, but there is no inverse secant, inverse cosecant, or inverse cotangent on your calculator. You would need to use these identities if you wanted to evaluate inverse secant, inverse cosecant, or inverse cotangent. Now, this should make sense. So remember, for the inverse trig functions, the inputs represent are ratios. And then the outputs, so this whole thing, inverse secant of that ratio, would be represent an angle. Okay. Inverse secant of a ratio would be equal to inverse cosine of the reciprocal of that ratio. So 1 over x represents the reciprocal of the ratio that we have over here. And that's for x less than or equal to -1 or x greater than or equal to +1. Okay, so that's just the domain of secant. Same thought process for inverse cosecant is equal to inverse sine of 1 over x. So inverse sine of the reciprocal of the ratio that inverse cosecant is being evaluated at. Inverse cotangent, because remember I pointed out back here that inverse cotangent has a very different range from inverse tangent. The range, remember, of inverse tangent is from -pi over 2 to pi over 2. Whereas the range for inverse cotangent is from 0 to pi. So quadrant 1 and 2 versus quadrant 1 and 4. If x is positive, inverse cotangent will be equal to inverse tan of 1 over x. So inverse tan of the reciprocal. That's because notice that for any of the inverse trig functions, all 6 of them, when the ratio that you are inputting into the inverse trig function is positive, you get an angle from quadrant 1. Quadrant 1 is included in the range of any of the inverse trig functions. When we restricted the domains of the trig functions so that they were one-to-one functions, quadrant 1, angles from quadrant 1 were included for all 6 of them. So if the argument here is positive, then inverse cotangent will be equal to inverse tangent of the reciprocal of whatever that ratio is. However, if the argument is negative, then inverse cotangent of x will be equal to pi plus inverse tan of 1 over x. And let me kind of draw a picture to explain that. So this is if the angle that you're solving for is, or that you're, this is if the angle that inverse cotangent represents is from quadrant 1. If the angle that inverse cotangent of x represents is from quadrant 2, meaning x is negative, we have to do inverse tan of 1 over x plus pi because inverse tan of 1 over x, if x is negative, will be inverse tan of a negative ratio. That would end up giving us an angle from quadrant 4. Okay, where this angle would be inverse tan of 1 over x. This is for if x is less than 0. However, inverse cotangent can only give us angles between 0 and pi. Cotangent is negative in quadrant 2. So inverse cotangent of a negative ratio is actually equal to this angle. So that's why we need to add pi to inverse tan of 1 over x, because inverse tan of 1 over x is actually a negative angle. So then when we add pi to that negative angle, it ends up giving us this positive angle. And I want to give us an example. Actually, we'll have an example in a minute. All right, so let's go ahead and find the exact value for each of these expressions. So using the identity, so inverse cotangent of root 3. Well, since root 3 is positive, that's equal to inverse tan of 1 over root 3, which if we were to rationalize the denominator would be the inverse tan of root 3 over 3 and is equal to pi over 6. Okay. Inverse cosecant of root 2 is going to be equal to inverse sine of the reciprocal, so 1 over root 2, which if you rationalize the denominator there would give us the ratio of root 2 over 2. And inverse sine of root 2 over 2 is positive pi over 4. Okay. Inverse secant of negative root 2 would be equal to inverse cosine of negative 1 over root 2. And if we rationalize the denominator there, negative root 2 over 2. Okay, so since it's a negative ratio, and this is inverse cosine, that's going to be 3 pi over 4. And let me give one more example where we have to use the identity, so the one that we were just talking about. So let's say inverse cotangent of negative root 3. That's going to be equal to pi plus inverse tan of negative 1 over root 3, which is pi plus inverse tan of negative root 3 over 3. Well, inverse tan of negative root 3 over 3 would be equal to negative pi over 6. Well, negative pi over 6 is not in the range of inverse cotangent. Inverse cotangent is between 0 and pi. So we have to add pi to negative pi over 6, giving us 5 pi over 6, which is in the range of inverse cotangent. It would be incorrect to just say inverse cotangent of negative root 3 equals to negative pi over 6. Negative pi over 6 is not in the range of inverse cotangent. We have to add pi. So inverse cotangent of negative root 3 would be equal to positive 5 pi over 6. Okay, so this type of problem is going to feel, or these problems are going to feel similar to problems that we have done before, but now they are also including the inverse trig functions. Okay, so if we want to find the exact value of sine evaluated at inverse cosine of 1/3, inverse cosine of 1/3 is going to represent an angle. Let's say the angle theta. Another way to think of that is that cosine of theta is equal to positive 1/3. Okay, inverse cosine of 1/3, because it's inverse cosine of a positive ratio, is going to give us an angle from quadrant 1. So if I draw this picture representing what I know, okay, this being angle theta in quadrant 1, cosine is the ratio x over r. So we know x would be 1. We don't know what y is. And we know r would be equal to positive 3. Well, we want to know what sine evaluated at that angle theta is, right? Because inverse cosine of 1/3 represents an angle. So we need to figure out what y is, because sine is the ratio of y over r. Using our handy-dandy Pythagorean theorem, 1 squared plus y squared equals to 3 squared. Y would be equal to the positive square root of 8, or 2 root 2. Meaning that sine of theta, or sine of inverse cosine of 1/3, would be equal to 2 root 2 over 3. Okay, this is similar. Let me switch colors. Okay, so we want to find what tangent evaluated at inverse sine of negative 3/7 is. Inverse sine of negative 3/7 represents an angle. Let's call that angle this time alpha. Sine, another way to write that is that sine of alpha equals to negative 3/7. Since it's inverse sine of negative 3/7, so a negative ratio, that's going to be a negative angle. Alpha will be a negative angle from quadrant 4. Drawing the picture. Okay, that would be our angle alpha rotating in the clockwise direction. Sine is y over r. So we don't know what the x-coordinate, the point that alpha passes through, would be, but we know y would be -3 and r would be 7. Tangent is the ratio y over x, so we want to solve for what x is using Pythagorean theorem. Okay, so 49 minus 9, that would be x equals to root 40 or 2 root 10. Okay, so tangent is y over x, -3 over 2 root 10, which if we rationalize the denominator by multiplying by root 10 over root 10, we get -3 root 10 over 20. And if you were to type this exact thing, the tangent evaluated at inverse sine of -3/7 into your calculator, you would get -3 root 10 over 20 as a decimal approximation. So you could always check your answer too. All right, this is just using an identity now. Ooh, bringing some identities in. Okay, so we want to find the exact value of sine of inverse cosine of 3/5 plus inverse tan of 1. Now, inverse cosine of 3/5 represents an angle. I'm going to call it alpha. Inverse tan of 1 represents another angle. I'm going to call that beta. Okay, sine of alpha plus beta. Well, you guys know what that's equal to. Sine alpha times cosine beta plus cosine alpha times sine beta. Sine, cosine, cosine, sine. Okay, we know that cosine of alpha is going to be equal to 3/5. But we don't know what sine of alpha. Oh, but we can find out easily what cosine of beta and sine of beta are. So I'll come back to that in a second. So let's focus on finding sine of alpha first. Okay, so for alpha, here, this is going to be, we're solving for sine of alpha. Okay, we are given that inverse cosine, another way to write inverse cosine of 3/5 would be cosine alpha equals to positive 3/5, which means that alpha is in quadrant 1, terminates in quadrant 1. Okay, that means x coordinate is 3. We don't know what the y coordinate is. R would be equal to 5 using Pythagorean theorem. We would get that y is equal to positive 4 since we're in quadrant 1. So sine of alpha, y over r, would be equal to 4/5. Now, for cosine of beta and sine of beta, notice that we're saying beta is equal to inverse tan of 1. Well, we know what inverse tan of 1 is. That's equal to pi over 4. And so if we were to substitute pi over 4 in for beta, I have some extra parentheses there. Cosine of pi over 4 is root 2 over 2. And sine of pi over 4 is also root 2 over 2. So we would have 4/5 times root 2 over 2, which would be 4 root 2 over 10. And then 3/5 times root 2 over 2 would be 3 root 2 over 10. And we have a common denominator, so if we add those two fractions together, we get 7 root 2 over 10. Sorry, I didn't have room for that last vertical step. So this big old yucky looking thing is equal to 7 root 2 over 10. Okay, and our last example, which is similar to the one we just did. So if you feel like you have it, you can go ahead and try some practice on your own. Try the homework. Okay, so cosine of inverse sine of 3/5 plus inverse tan of 1. Well, I'm going to call inverse sine of 3/5 alpha, and inverse tan of 1 is an angle, beta, or I'm going to just right away write that as pi over 4. So I would have cosine of alpha plus pi over 4 would be equal to, using the identity, cosine alpha cosine of pi over 4 minus sine of alpha sine of pi over 4. We don't know what cosine of alpha is. We do know that cosine of pi over 4 is root 2 over 2. Sine of alpha is 3/5. And sine of pi over 4 is root 2 over 2. So really, we just need to determine what cosine of alpha is. So since sine of alpha is equal to 3/5, which I know from this statement here, that means that alpha is going to be terminating in quadrant 1, right? Because inverse sine of a positive ratio gives me an angle from quadrant 1. To draw that picture, okay, we don't know x, y would be 3, r would be 5. Pythagorean theorem. So we would get x equals to positive 4, since we're in quadrant 1. So cosine of alpha would be 4/5. So 4 root 2 over 10 minus 3 root 2 over 10 is actually going to just be root 2 over 10. So this is equal to root 2 over 10.